In this tutorial video, we will be learning about understanding data types in Python. We will learn how arrays of data are handled in the Python language itself, and how NumPy improves on this. Now let me give you some basic difference between C language and Python. Some basic difference are in variable declaration. In C or Java language, requires each variable to be explicitly declared. While in Python the equivalent operation could be written this way as follows. And another difference is switching the contents of an integer to a string. In Python language, naming is faxable and we can assign any kind of data to any variable. But in C and Java language, naming is not faxable and we cannot assign any kind of repeated data to a variable. A Python integer is more than just an integer. Every Python object is simply a cleverly disguised C structure. Integer in Python are actually a pointer, which contains several values. A single integer in Python 3.4 actually contains 4 pieces. They are, number 1, a reference count that helps Python silently handle memory allocation and deal location. Number 2, which encodes the type of the variable. Number 3, which specifies the size of the following data members. Number 4, which contains the actual integer value that we expect the Python variable to represent. There are some overhead in storing an integer in Python, as illustrated in the following figure. Notice the difference here. A C integer is essentially a label for a position in memory whose bytes encode an integer value. A Python integer is a pointer to a position in memory containing all the Python object information, including the bytes that contain the integer value. A Python list is more than just a list. The standard mutable multi-element container in Python is the list. We can create a list of integers as follows. And we can check its type. And we can also do the same thing to the string list. We can create a list of strings as follows. And we can check its type like before. Because of Python's dynamic typing, we can even create heterogeneous lists. But this flexibility comes at a cost. To allow these flexible types, each item must contain a complete Python object. The difference between a dynamic type list and a fixed type array is illustrated in the following figure. The Python list contains a pointer to a block of pointers. Fixed type NumPy style arrays lack this flexibility, but are much more efficient for storing and manipulating data. Python offers several different options for storing data in efficient, fixed type data buffers. The built-in array module can be used to create dense arrays of a uniform type as shown below. Here I is a type code indicating the contents are integers. Now let's try on Google Colab. Much more useful, however, is the endArray object of the NumPy package. While Python's array object provides efficient storage of array-based data, NumPy adds to this efficient operations on that data. For creating arrays from Python lists we will do it on Google Colab. We need to import NumPy. First, we can use np.array to create arrays from Python lists. Remember that unlike Python lists, NumPy is constrained to arrays that all contain the same type. If types do not match, NumPy will upcast if possible. If we want to explicitly set the data type of the resulting array, we can use the type keyword. Finally, unlike Python lists, NumPy arrays can explicitly be multidimensional. Here's one way of initializing a multidimensional array using a list of lists. Nested lists result in multi-dimensional arrays. The inner lists are treated as rows of the resulting two-dimensional array. For creating arrays from scratch, we will be doing it on Google Colab. Especially for larger arrays, it is more efficient to create arrays from scratch using routines built into NumPy. Here are several examples. Creating a length of 10 integer array filled with zeros. Here it create a 3 by 5 floating point array filled with ones. Create a 3 by 5 array filled with 3.14. Here it create an array filled with a linear sequence, starting at 0 and ending at 20, stepping by 2. It create an array of 5 values evenly spaced between 0 and 1. It create a 3x3 array of uniformly distributed of random values between 0 and 1. Create a 3 by 3 array of normally distributed random values. Create a 3 by 3 array of random integers in the interval 0 to 10. Create a 3 by 3 identity matrix. Lastly, it will create an uninitialized array of 3 integers, and the values will be whatever happens to already exist at that memory location. Here are some NumPy standard data types. Thank you for watching this video, and please subscribe to our channel.